Hello everyone, welcome back. And today we are going to learn the linked list data structure from scratch. This is a really important data structure for interviews. And after we go over the structure, then we'll solve the most classic linked list problem ever, reversing a linked list. You've definitely heard of it. And if you can reverse a linked list, a ton of other linked list problems start making more sense. So it's really important to know this. So what is a linked list? So right here, a linked list, as you can see here on this diagram right here. So a linked list is basically a chain of nodes, and this is a node right here, as you can see. And each node stores some data and a pointer to the next node. So the data is here, and the pointer to the next node is right here next. And you see the arrow, right? That pointer, the pointers here that you see throughout this linked list is what links everything together. So now let's just break down the node here. So look at one node. It has the two parts, like I said, right? The left side has the data. That's like a number, 1, 2, 3, whatever you're storing in the list. And the right side is the pointer, the next pointer. It stores the address of the next node. So the node doesn't store the next value. It stores where the next node lives, right? That's what it does. Just so you understand that. And now you probably notice this here. What is this head pointer right here? The head pointer is the entrance of the whole list. If you have a head, you can reach everything in the list. If you don't have a head, you don't have a list. It's that simple. And you all probably also notice this null at the end right here. So null means there is no next node, and that's how you know you're at the end of the list, because there is no index in a linked list. So when you reach null, that's when you know you reached the end of the list. So now I already explained in some ways how it's different from an array, but I'll just go over it again. So the big differences from arrays are, in an array, you can jump to an index instantly. Let's say you can just jump to index 50 instantly. In a linked list, you can't really jump. If you want the fourth element, you have to start at the head, start all the way at the head, and then you have to go and follow the next one and the next one until you reach the fourth element. So array has random access, but in a linked list, you have to traverse the linked list to get to a certain element or value. So why are linked lists useful? So why would you use a linked list at all? Because pointers make insertions and deletions really cheap and really easy. So if I'm in the middle of the list and I want to insert something, I don't have to shift a bunch of elements around like an array. I just change a couple pointers and bang, it's in the list now. But the trade-off here is the traversal, like I said before. So linked lists are slower if you constantly need to access by index. So also another common trap I'll say right now is the number one linked list danger is, well, linked list problems do feel scary because you can lose the list if you mess up the pointers. So if you overwrite the next pointer before saving it, you've basically cut off the rest of the chain here. So if you're ever changing something, you have to make sure you save the next before you change it. Alright, so now let's jump into the problem reversing a linked list or reverse linked list. So we see here an example. I just drew a smaller example. Instead of 1, 2, 3, 4, 5, I just drew 1, 2, 3, but that's fine. And what we want to do is reverse it. So we want to reverse the direction of every arrow here. So we want to make this, in the end, we want to make this 3, that points to 2, that will point to 1. We're just reversing the arrows here. Not the element itself, just the pointers. So I'm going to walk through this list, the list with 2 pointers, the 2-pointer method. So current is good. We're going to have a cur, right? current is going to be the node I'm currently on, and previous is going to be the node behind me. So at the start, we'll have, let's call it previous. So at the start, previous is just going to be here, it's just going to be null, right? I'll just have it as null because there's nothing behind the head yet. And the head's up here, obviously. I just drew that so I have room for the null for the previous. So there's nothing behind the head yet, and the current, we'll have the current pointer to start at 1 here. Let's start at 1. The current node, the node I'm currently on. So the one problem here we have to avoid is if I change where current points, I might lose access to the rest of the list. So before I reverse anything, I always quickly want to save the next node in the temporary variable. So I would have, so if the current is at 1, I want to save the next node 2 in a temporary variable or like a temporary bookmark. But I'll explain that in the code when we walk through the code actually and start coding it out. So now, right now, current is at 1, right? And the next node is 2. So I bookmark 2. And now I reverse the arrow at 1. Instead of pointing at 2, 1 should point back to previous, which is null. Right? And then now this arrow here is gone. Right? Because now 1 is just pointing back to null. And now I move forward. So now you move the pointers forward now, and now current will go to 2, right? And then now this isn't the current anymore. This will now be the previous. We'll bring the previous up to 1. And the current moves to the bookmark node 2. Bookmark node 2. So now at node 2, same exact thing at node 2. We want to remember the next one. We want to bookmark the next node to make sure we don't lose a list. So now we'll just, our next will be 3. And now we reverse the arrow at 2. Now it points back to previous. So now 1 points to 2 now, right? And now we move forward again. Now current becomes 3. And then now this isn't the current anymore. Now the previous will also move up. This is now the previous. So previous becomes 2. Current becomes 3. But now we bookmark the next node, but this time it's null. We're at the end because 3 is the last node. So next is now null. And then we reverse the arrow here at 3. So now this now points back to 2 now. And then now you'd move these pointers up again. Now this isn't current. Current is now null. And now this is previous 3. And now when current hits null, this will be one of our conditionals. When current hits null, that means we're done. And previous is now pointing at the new head. So the answer is previous. So this is the new head. So this will be the answer, what we're returning in the end. So now the code is literally just doing the same move in a loop. Bookmark the next node, reverse the link, and slide forward, slide the pointers forward. So now we can start coding this up here. Also, one more thing that I failed to really visualize here, which is my fault, and also to avoid confusion, is now that 3 is pointing this way, this pointer does not exist anymore. Right here, this pointer is gone, does not point at null anymore because 3 is the new head. Null is now on this side, and same thing here with 1. This pointer doesn't exist anymore. This is the new pointer, points at null. Just to clear that up, now we can go on to the code. Alright, so now let's start coding this solution up. So let's just get right into it. So as always with linked lists, we want to walk through the list once and flip pointers as we go, like I said before. So I'm going to keep 2 pointers. We're going to have a previous pointer and a current pointer. And a temporary next that I'll define later, so we don't lose the rest of the list. So technically 3 pointers. So previous will start at null, like I said. Previous starts at none because the new tail should point to null. And then current will start at the head of the list right now. So that head. And now we want to loop through the list now and flip the pointers. So we're just going to do while current. And this means now while current exists, we're still processing nodes. So when current hits null, that's when we know we're at the end of the list and we finished reversing it. So now inside the loop, every iteration is the exact same 3 moves. So first, this is where we're going to store the next pointer, bookmark where we're going next. So next will equal current dot next, which points to the next node. And then we want to flip the arrow now. Current dot next equals previous. This will point back to the previous node. So this will point, in this first iteration, it'll point 1 to null, right? The previous is null right now. And then we want to move forward. So now previous will now be the new current. And then the new current will now be the bookmarked node next, right? So let's just go over this again. So first line is a safety line. I'm saving the rest of the list. And then now here is the reversal that flips the arrows. Then you slide both pointers. Previous moves up, becomes a new front of the reversed part, and current is moved to next, the next node I originally saved, just to restate what I coded here. And then when the loop ends, current is null, like I said, meaning we reversed everything. So the new head would be previous now, right? So then you would simply just return previous here because that's the new head. And if we run this, it should pass the test cases and then submit it. And there you go. It's the optimal solution.